Today we're going to talk about how to find inverses of a matrix. Of course, an inverse implies that there's an identity object for that operation. And for multiplication of matrices, this is the identity matrix. That implies that there should be inverses. So let's see. 2, 4, I'm sorry, that's not going to work. Let's try this. 3, 4, 2, 3 times 3, -2, -4, 3. Let's multiply these together to see what we get. Well, it's going to be a 2 by 2 matrix, so we'll do each element. The first is going to be row 1, 3, 4 times column 1, 3, -2. And that's 9 minus 8, which is 1. Then we're going to do this one, which is row 1, column 2. We can clearly see that those are opposites, so that's going to be 0. Then here it's going to be row 2, column 1. Again, these are opposites, going to give me 0. And then last of all, we have row 2, column 1, 9 minus 8 is 1. So these multiplied give me the identity. Turn them around and multiply, you'll still get the identity. So the question is how do we know whether things are inverses? Well, we multiply them together and see if we get the identity matrix. To show you how easy this is, let's take these two matrices. 2, 1, 3, 6 times 6, -1, -3, 2. Let's take row 1, column 1. This is 12 minus 3, that's 9. So I'm not getting a 1 in the first position. I get a 9, so it's out. So as soon as you get anything other than one of those numbers, you know that there is no inverse. Now, how do I go about finding the inverse? Let's take this matrix, 2, 4, 5, 9, and we're going to try and find its inverse. As it turns out, the way that we can do that is to extend this and we'll work this one backwards to be the identity matrix on this side, and then this will be working the inverse way for this over here. So this then will end up being the inverse. So let's do that. I'll keep a working matrix over here. The first thing we want to get is a 0 in this position. So let's switch the 4 and the 2, make one negative, and we'll multiply them. And we'll get 8, 20, 4, and 0. And when I multiply, I get -8, -18, 0, and -2. Add them together, 0, 2, 4, -2. And remember that anytime I have a row, I can always divide it by a number And these can all be divided by 2. So we'll do that. And this will give us a bottom row of 0, 1, 2, -1. Now the next thing that we want to do is to create a 0 in this position. So now I'm going to take these two and I'll switch the 1 and the 5, and let's make the 1 negative. And if we do that, we get -2, -5, 1, and 0. And on the bottom, 0, 5, 10, and -5. Add these together, you get -2. This should have been a -1. There we are. 9, 0, and -5. And so now let's replace that in the top row. -2, 0, 9, -5. Now, we want this to be a 1, so that means we have to divide that row by -2. So dividing this row by -2 will give me a 1. And this will be -9/2, and this will be +5/2. Okay? And that means that this is the inverse of what we started with. Now, if I look at this matrix, a lot of us don't like to do matrix multiplication addition when we have fractions. So oftentimes, if we have fractions, we will simply factor out. In this case, I'm going to factor out a -1/2. And that will change everything. That will give me this matrix. Let me write it down. That will give me the matrix -1/2, 9, -5, -4, 2. And notice, if we compare that to our original matrix, notice these 4 numbers are the same as these 4 numbers. They've just been rearranged. If we think that this is a pattern, I could do many examples and we'd all come up with the same pattern. That these 2 numbers are switched and these 2 numbers are made opposites. But where does this come in? How can I figure out what that is? Well, let's take the determinant of this matrix, the original matrix. It's 18 minus 20. The determinant is equal to 18 minus 20, which is -2. And the inverse of -2 is -1/2. So this number here is the inverse of the determinant. And so this gives us a method, as we say, a kind of a shortcut method, knowing the pattern of how we can quickly find the inverse of a 2x2 matrix without having to go through all of this matrix manipulation. And so now let's take a look at doing our inverses by using the pattern for a 2x2 matrix. Let's just throw some out there. 2, 3, 5, 6. What will be the inverse? Remember the pattern? switch, opposite, one, and inverse determinant. Okay, well the determinant is going to be 12 minus 15, which is negative 3. So I'm negative 1/3. And then we're going to switch these two, 6 and 2, and make these opposite, negative 3, negative 5. And there I have the inverse of this 2 by 2 matrix. Here's another one, just so you get the idea. And this will be negative 5 minus 12. So that's 1 over negative 17, or negative 1/17. And a switch and make opposites. And there you have your inverse. So when we apply inverses, that's what we get. Let me give you one to do for practice, and then pause, do it, and see if you get the right answer. Okay, hit pause, do your problem, and then come back to check your answer. All right. Notice I found the determinant. The determinant was negative 1, so the inverse is negative 1. Then I switched these two and made these opposites. Switch, make opposites. But rather than having a negative 1 out here, you just go ahead and multiply negative 1 times the inside, and that gives you the other matrix. Still doesn't have any fractions, and so it was an easy simplification to avoid just having a negative sign in front. Now, how can you know that an inverse does not exist? The key is in this right here, 1 over the determinant. If I take this matrix, the determinant is 12 minus 12, which is 0. 1 over 0 is undefined. And therefore, if I have a matrix where the determinant is 0, this part of the inverse would be undefined. Therefore, the inverse does not exist. And we say that this is a singularity. Which either means that it's a system, it could be part of a system that has no answer, or part of a system which has infinite number of answers. We would have to have more information to be able to know that when we're using it in an application. So that's finding a determinant of a 2 by 2 matrix.